The motion of two particles is given by the vector functions shown here. So one particle is r as its position vector and the other one is q. We want to calculate the position at which the particles collide. Well, if they're going to collide, their I components must be equal and their j components must be equal at the same time. So what we're saying is that 3t must be equal to 8 minus t, and that t squared minus 3t must be equal to 3t minus 8. Now clearly it's easiest to work with 1. So 1 would give us that 4t is equal to 8, and therefore t is equal to 2. Now we could go ahead and solve the quadratic, but the easiest thing to do is for 2, just look at the left hand side. So that will be 2 squared minus 3 times 2, which gives us negative 2. And if we look at the right hand side, that would be 3 lots of 2 take away 8, which is also negative 2, and that indicates that they do collide, that the j components would be the same. So the position vector where they collide is when t is 2, so that would give us 6, and we've already got it from here, negative 2. We now want the distance between the particles when t is 1, so let's look at r of 1. That's going to be, substitute 1 in for t, and that would be 3, and 1 take away 3, so that would be negative 2, and q of 1, so that's 8 take away 1 is 7, and 3 take away 8 is negative 5. So one point is at 3, negative 2. The other one is at 7, negative 5. And the distance between them would be this straight line here. So let's just form a right-angled triangle. 3 going across to 7 is 4. Negative 2 going down to negative 5 is 3. And that's a 3, 4, 5 triangle, so the distance is equal to 5.